Good evening. Yesterday we have started the waves and completed the waves. And we have started one problem and we have solved in the previous class. The next problem, if two waves of wavelengths 50 centimeter and 51 centimeter produced 12 beats per second, the velocity of sound is, the question is asked, what is the velocity of sound? Velocity of sound is dash. Such that the problem asked in the NEET examination and any other centrally sponsored examination is there. So here the first step I already told in the previous class what is called beat. Beat is nothing but change in frequency or number of beats produced per second can be calculated by difference of frequencies. So here the value 12 is given. Therefore n1 minus n2 is equal to 12. So the first step, n1 minus n2 is equal to 12. Immediately you have to ask question yourself, why sir we are putting n1 minus n2 instead of we can call n2 minus n1? Is it possible? I already told in the previous class, the frequency inversely proportional to length. The frequency inversely proportional to length. That means if length is more, frequency is less. There are two parameters given in the problem, 50 centimeter and 51 centimeter. L1 50, L2 51. Therefore, lesser distance have more frequency. Therefore, nu1 greater than nu2. So that I put n1 minus n2 or nu1 minus nu2. Whatever may be there. Nu1 minus nu2 is equal to 12. Some book they are using the word nu. In some other book they are having n1. Whatever may be the case, the frequency difference. But we already know the relation between the velocity, frequency and wavelength. Because wavelengths are given in the problem. So, what is the importance of this problem is, in some book they are using, and even you are understanding to get the answer, in order to solve, what are the parameters we have to use, quickly we have to solve. So that is a technique I want to discuss, so that I took this problem. V is equal to nu lambda, therefore nu is equal to V by lambda. For nu1 minus nu2, so nu1 V by lambda 1, that is 50, minus nu2 V by 51 equal to 12. So from these consequences, we have to find out the value of V. So it is very difficult. So that the question, kindly go through the problem. The parameters given in centimeter. If centimeter converted into meter, that should be multiplied by 10 power minus 2. Or if 10 power minus 2 goes in the numerator, what happens? 100 divided by 50. So that is an importance of shortcut method. 100 divided by 50 meter. Here also 100 divided by 51 meter. So this can be cancelled by 2. So this can be modified as 2V minus 100V by 51 is equal to 12. So we have to solve the problem very easily. Otherwise, you have to take the LCM or it is in the fraction. It is very difficult to solve the problem. So here also, if it is 51, the common LCM becomes 51. 51 into 2, again 102, V minus 100V is equal to 12. 102 minus 100, 2V by 51 is equal to 12. Therefore, V is equal to 12 into 51 by 2. 12. 2V by 51 is equal to 12. Isn't it? Or 51 into 12 by 2 by 6 times. Therefore, 306 meter per second is the correct answer. So, if you are not using the meter, it is very difficult to solve because 150 minus 1 by 51, the value we cannot find easily. So that it should be converted into meter, automatically 100 divided by something. We are using this step for getting the answer. So go for third problem. A wave of frequency 500 Hz travels between x and y distance of 600 meter in 2 seconds. How many wavelengths are there in the distance xy? So this is again the substitute for all. We know velocity is equal to displacement by time. So here 600 meter in 2 seconds. Therefore 300 meter per second. So what is the velocity of this problem? Simply 300 meter per second. How can I calculate? Velocity, rate of change of displacement. That means displacement by time. In the problem, 600 is a displacement in 2 seconds. Therefore, velocity can easily calculated 300 meter per second. The same formula, P is equal to nu lambda, from which lambda is equal to P by nu. That is equal to velocity, just we calculate as 300 divided by frequency given in the problem as 500. Therefore 3 by 5 meter. The wavelength is 3 by 5 meter. What is our question? How many number of wavelength? So I got each wavelength is 300, 3 by 5. So how many number of waves in 600 meter? Therefore number of waves in total distance 600 meter. That is n is equal to x by lambda. Here x is 300 by 3 into 5. So this can be 200 into 5. That is 1000 is the answer. Or this is, it is called 1000. So it is called 1000 is the correct answer. Number of waves in 600 meter, 1000 waves are formed. Very interesting problem this. Definitely it comes in your future, no problem. Problem 4. 2 sound waves with lambda 5 meter and 5.5 meter respectively, each propagate in a gas with velocity 330 meter per second. Calculate number of bits. It is a reverse problem. So already given the number of bits. Here they are giving the velocity from which and wavelength from which number of bits can be calculated. That is 342 sound waves. We know V is equal to nu lambda, the same formula, or nu is equal to V by lambda. That is equal to 330 divided by 5, 66. For second case, nu is equal to 330 divided by 5.5, 60. The difference in frequency is called beat. Therefore, 66 minus 60 is equal to 6. So, how many number of beats are produced? 6 is the number. So, kindly make note, a very easy problem, this also. So, another problem. The speed of wave is 360 meter per second and the frequency is 500 Hz. Phase difference between the wave is 60 degree. what is the path difference. So in all the classes, if you are thorough on here, that is also very easy for 12th standard. We are given the solution that relation between the phase difference and the path difference I already given. That means the phase difference phi is equal to 2 pi by lambda into path difference. If you know path difference, easy to find out phase difference. If you know the phase difference, path difference can be calculated. So here 60 degree, that is a point to be noted here. The phase difference between the wave is 60 degree. That should be converted into radian. Then only it is possible. Therefore, 60 degree is nothing but 180 by 3. Isn't it? Therefore, path difference is equal to pi into lambda by 2 pi. Here also the wavelength, that is pi by 2 pi. What is wavelength lambda? V is equal to nu lambda, or lambda is equal to V by nu. That is we have to convert it. Given parameter V by nu. So simply substitute here. Pi 60 degree. 60 degree is nothing but 180 by 3. 180 is nothing but pi radian. Pi by 3. That is given is pi by 3 into what is the velocity? The speed of wave is 360 divided by 2 pi. What is the frequency is 500 Hz. So this pi getting cancels. This 360 cyber getting cancels. This may be 12. 12 by 50. That is equal to 0.12 by 100. 0.12. 0.12 meter. If the phase difference is 60 degree, what is the path difference? Path difference becomes 0.12 meter is the correct answer. 0.12. So what are the concepts here involved? How much we have discussed for the first 2 days about waves. First concept is the relation between path difference and phase difference. The second concept is V is equal to nu lambda, from which wavelength should be calculated. The third concept is we have to convert the degree into radian. Then only it is possible to find out the answer. So the next problem. A source of sound is moving with constant velocity 20 meters per second and emitting a note frequency 1000 Hz. The ratio of frequency observed by stationary observer while the source is approaching him and after it crosses him, what is the value? So when you read out the problem itself, in which chapter it comes, immediately it should be flashed in your mind. Then only we can solve any kind of problem. Otherwise very difficult. If source and observer comes, you can come to the conclusion that this is nothing but Doppler effect. I already given the standard formula for Doppler effect. Therefore, what is the frequency? So the frequency of observer and the frequency of the source equal to V plus Vs by V minus Vs. Because observer is at rest, the source sometimes approaches you and then beside you. When it comes very close, V plus Vs. When it away from this, V minus Vs. That is equal to 340 plus 20 by 340 minus 20. That is equal to 360 by 320. That is equal to 9 by 8. That is that while the source is approaching. A source of sound is moving with a constant velocity 20 meter and emitting a note frequency 1000 Hz. The ratio of the frequency of observed by stationary observer while the source is approaching, that is called nu A, while the source is residing, nu R. The ratio nu A minus nu R is equal to 9 by 8. So why this 1000 Hz gives the problem? Not to confuse you. So you need not go for all the parameter should be involved in the problem. Take the necessary parameter and be able to find out. Otherwise it is very difficult to find. Okay. So take one more problem. I will give one more problem to you, important problem for this. So kindly make note of that problem. Very, very important problem. Take that. There is a repeated problem in all government examinations. So that I am giving addition to a slide. So kindly read out. I read out. Kindly note it. The fundamental frequency. The fundamental frequency. The fundamental frequency of a closed organ pipe. Closed organ pipe is 220 Hz. Very important problem, so that I am read out. The fundamental frequency of closed organ pipe is 220 Hz. If 1/4 of pipe, if 1/4 of pipe is filled with water, is filled with water, the frequency of first overtone dash. So I put this problem, so you should not confuse. The fundamental frequency of closed organ pipe is 220 Hz. If 1/4 of the pipe is filled with water, what is the frequency of first overtone? So one thing here we have to remember that we are studying the organ. Organ means air. Any instrument operated by air is called organ. So in this pipe, 1/4 of the pipe is filled with water means remaining 3/4 is air. That is a point to be noted. Generally we know V is equal to nu lambda. That V, that is our nu is equal to V by lambda. That is given as 220. This is given in the problem. Or we know the fundamental frequency of closed organ pipe. If it is in closed organ pipe, the fundamental frequency formula is V by 4L. Don't forget it. V by 4L. V by 4L is 220. Therefore, V is equal to 220 into 4L. This is a first step in noted. So the same problem cannot be asked for open organ pipe because we cannot fill the water in the open organ pipe. Closed organ pipe means one side is closed, so that everything is filled. The remaining 3/4 is empty, that is air column. So 1/4 is filled with water means 3/4. For 3/4 is air. For that fundamental frequency. What is the fundamental frequency? For 3/4. That is V by 4L. So here L is 3 by 4L. That is a difference. So here directly 4L, full length. If it is full length, 220. If it is 3/4 L, 3 by 4L. or V by 3L. V by 3L. That is equal to for first two overtone. The question is asked the frequency of first two overtone. What is the ratio of the frequency in the closed organ pipe is 1:3:5. 1 is called fundamental frequency. The first two overtone frequency is 3 times the fundamental frequency. Therefore, this will be multiplied by 3. So 3 getting cancelled. Therefore, answer is V by L. I already given V value 220 into 4L divided by L. L getting cancelled. 220 into 4, 880. 880 hertz is the answer. Can you follow this problem? Very important problem. It is a repeated problem in so many examinations, centrally sponsored examination. Okay, so that purposely I have given this problem. The fundamental frequency of closed organ pipe 220 hertz. If 1/4 of the pipe is filled with water, calculate the frequency of first two overtone. The question is first two overtone. The first two overtone frequency is 3 times the fundamental frequency. So first I calculate the fundamental frequency V by 3L. That should be multiplied by 3. Automatically V by L. V already given as 220 into 4L. LL getting cancels. We are getting 880 hertz. Okay. So this is a important thing you have to understand.